Hi everyone, I'm Nayana Swain, a mentor here at STEM Scholars, and today I will be giving you a brief introduction to planet formation. So, what are our learning objectives? First, what are planets and how do we distinguish them from other celestial bodies? Second, what is the general process through which planets in our solar system form? Finally, why is knowing the process so important? What is a planet? Most of us are familiar with the concept of a planet, but chances are, if you were asked the question, what is a planet? You would find it difficult to answer the question and define the concept without using examples of planets like Mars and Jupiter. And so, before we delve into the process with which planets form, it is important to have a clear understanding of what a planet even is. By definition, a planet is a large, rounded astronomical body that is neither a star nor its remnant. So, if a planet is large and rounded, why is our friend Pluto here not a planet? That's because there is more to a planet than its definition. Not only must a planet be rounded and large, but it also needs to have something known as orbital dominance, which means the planet needs to clear its surrounding area in which it is present of asteroids and other small bodies. And this is the reason why Pluto is not a planet. Because while Pluto is sufficiently rounded and large, it does not have orbital dominance because it has not cleared its surrounding area of smaller bodies like asteroids. So, how do planets form? And the simple answer is that we don't know. There is no one conclusive explanation that explains how all of the planets in the universe formed. But we do have some theories, and today we will learn the theory that is thought to explain the formation of planets in our solar system. And this is extremely important to note. The video today will be covering the formation of planets in our solar system, the way in which exoplanets or planets outside our solar system form is very different from the planets in our solar system. So make sure when you're listening to this lecture to be thinking about the planets in our solar system, such as Earth and Mars. But without further ado, let's get into it. The theory thought to explain the way in which planets in our solar system formed is known as the Nebular Hypothesis. This hypothesis was first conceived by astronomer Emanuel Swedenborg and then refined by Immanuel Kant, and it is where it is today. So, there are four large steps to this hypothesis. We first begin with a nebula, then onto the formation of a protoplanetary disk, then to the process of accretion, and end up with the final result of a planet. Let's delve deeper into each of these steps, beginning with a nebula. A nebula is essentially a giant cloud of nebular gas and dust. And what's important in this nebula is that after the presence of a nebula, there was gravitational collapse in the center of the cloud. And the causes of this gravitational collapse aren't known with certainty, but there are some probable theories, such as gravitational pull from a passing star, or maybe shock waves from a supernova, which is a dying star. And following this gravitational collapse, we created something known as a protoplanetary disk. After the collapse of the nebula, pockets of dust and gas began collecting into denser regions. Denser regions pulled in more matter, and then, to conserve momentum, rotation began. And as this rotation began, heat was generated in these pockets of gas and dust. The hot mass or ball at the center of this pocket or protoplanetary disk became the sun, and the rest of the mass was flattened out into a disk like structure, which is known as a protoplanetary disk. So, this right here, is theorized to have become the sun, and all of the stuff around it is what our planets in the solar system are made out of. Then we move on to the process of accretion. The word accretion quite literally means coming together, and I want you to keep this in mind as we discuss the concept of accretion. And also a small note, a protoplanetary disk is also sometimes referred to as the accretion disk. So this can also be an easy way to remember the concept of accretion. In the protoplanetary or accretion disks, the atoms and molecules begin colliding and sticking to one another, creating large spherical structures. And as with the formation of the protoplanetary disk, the larger the structure gets, the stronger the gravitational pull. And so more and more matter was pulled in until we had a structure large enough to be called a planet. So we end up with a planet. But this still fails to explain why planets in our solar system are arranged in the way that they are. If every planet in our solar system followed this process, why does each planet have different compositions and types? There is an explanation for this. This is known as the planetesimal theory. And this planetesimal theory revolves around the concept of a snowline. So, I want you to imagine our solar system in a straight line, starting with the sun here, Mercury, Venus, Earth, Mars, etc., until we end with Neptune. You may notice that planets closer to our sun, such as Mercury, Venus, and Earth, are rocky and dense, while planets further away, such as Saturn and Neptune, are icy gas giants. And this is exactly what the planetesimal theory explains. Inside the snow line contains rocky and dense planets like Earth and Mars because heavier elements were pulled in by the sun's gravitational force, which leaves icy gas giants forming outside the snow line. And if you are having trouble imagining the imaginary snowline, the snowline is located somewhere between Mars and Jupiter. So inside this line, we have rocky, dense planets, and outside we have icy gas giants. And this formation is known in a collective term of orbital configuration. So, why does the process of planet formation even matter? Why do we care? Why do we spend so many resources trying to understand the process? And the answer is that understanding the way in which our own solar system formed and other planets formed is crucial to understanding how our universe was formed. The more we learn, the easier it becomes to understand the process and support theories such as the Big Bang Theory that you may have heard of. The more we learn about smaller processes in our universe, the closer and closer we get to answering the question, how did the universe come to be? So hopefully today's video was helpful in giving you an introduction to planet formation in our solar system. And don't forget to check out other STEM Scholars videos to learn other cool concepts that you may be intrigued about or have questions about. Thank you for listening.